Hello class, in this video we're going to talk about two advanced features of at-risk, distribution fitting and risk optimizer. So if you remember in previous video, we generate a demand following say a normal distribution with given parameters. But how are you sure that the demand follows a normal distribution, and how can you sure the mean and the standard deviation for that distribution? Most of the time, we only have historical data, and we want to use that historical data to predict our demand. In this worksheet, we give you a series of data which belongs to the historical demand, and we're going to use this to generate empirical distribution and use that distribution for our random variable generator so that we use the historical demand information to predict the demand, and based on that prediction, we make a decision. So the function we're going to use is distribution fitting, fit u1. So probably because I have already established a fitting, so it gives me that window, but you probably don't have that. So this range would ask you to input the data range. So the default is right, so we can continue with the fit, and it gives you a normal distributions you see as the best choice. And there are other alternatives like Weibo or Gamma. You can take a look at these distribution, and say if you look at a triangle, it may looks like that. It seems is a normal give you a better fit to this. After you get the distribution, you can look at the mean and standard deviation of this distribution and use this distribution to generate random demand. So we click write to cell, and this is the formula you're going to use in this write to cell, and click next. And we're going to put the demand in our simulation model here and press OK. If you have formula in this demand function previously, then you should have to move that the function and only retain this function in this demand cell. Now every time you hit F9, you generate a new demand. As you can imagine, this new demand is following the same pattern from our historical demand. So our next goal is to find an optimal order quantity that maximizes our expected profit. The way to do that, you can use the risk semi table to evaluate these alternative order quantity. But today we're going to use a new techniques called the risk optimizer. Before we do that, you have to empty the formula within this cell. You can just enter any numbers here. And we can first define our model. And as you see here, this is a maximizing problem. So we're going to choose maximize, and the profit cell, which is F13 here. This is the cell we want to maximize. We want to maximize in terms of the mean. That's we want to maximize the average profit. And then we add the decision variable here. This is B line, which is our order quantity. This is the one we want to adjust it. So if you don't have one, you can click add, so you can add this cell as your decision variable. Let me delete this original one. Let me delete this for all and then start over. So we can add all the quantity here. And then we have to specify the range we want to search. Let's say 125 to 250. This is the range we want to search for this optimal. Press OK. Now we can start to run this model by click Start. And you can look at the progress of this searching procedure by icon. And you can see this is historical. This is the history of all the search procedures. Start from this 2,200 profit, and an increase to 2,045, and it's kind of stable, means we probably already have the optimal order quantity. As you see here is 172, so that should be the optimal order quantity we should have. So we look at the summary. This is exactly the process the searching process we just observed. We can close this, and we can also browse this result. This is the distribution of the profit and this order quantity. As you see here, 90% of the chance our profit will be between 206 to 3,446. We can drag this around to see different range of our profit and what's the corresponding probability the profit within this range. And you can also browse the result by click Excel reports. And that's all for this video. Thank you.